Welcome, everyone, to Robotics X Tokyo's October meetup, October 2024. I'm going to actually mute my device here so I don't hear myself. There we go. So this event, we called it Robotics X Halloween because it's Halloween, but what the topic is going to be tonight is Robotics X Construction, and we have a few members here in the both construction industries and robotics industries. First, I just want to give you a brief introduction to who I am and what the group is. So my name is Mike Sudano. I'm dressed as a vampire, and contrary to what vampires like, tonight I do not want to suck. So please give me good feedback. Thank you. I told you there was a joke associated with the costume. Yeah, so I'm originally from New York City. I moved out to Silicon Valley and I was working there for about 10 years, a variety of robotics companies and startups, and then moved out here to Tokyo about 4 or 5 years ago and founded Robotics X Tokyo with a couple of other members based on Silicon Valley robotics. And we used to have events called Bots and Beer, and luckily CIC Tokyo, Venture Cafe Tokyo gave us this venue to use pretty much every month, every other month, pro bono, and it's very awesome of them. So I recommend people come down here for their Thursday gatherings every week as well. But we've been running for about 2 years, I think, and as you can see, we have 770 members on Meetup, which is insane. We also have a LinkedIn group that's about 3 or 4 months old, and I think we just cracked about 200 members on there. So please join, tell your friends, anybody who's interested in robotics to get on that. So yeah, that's me, and then I'll let the other members introduce themselves and their backgrounds, and we can go from there. Take it away, Stephen.
Hi everybody, can you hear me? Yes, you can. Stephen Daff, I'm part of the corporate venturing team over at Hitachi Construction Machinery. So I am the least robotic proficient person probably sitting on this panel. Usually take a little bit more of an angle on how we can do things in terms of improving on construction sites. So I'll bring sort of the corporate voice, I think, to the discussions this evening. You can probably guess I'm not Japanese, but I've been here for about 13 years now, so quite some time over here in Tokyo in a variety of different positions. Now with Hitachi, but before that in the automotive space. So nice to meet you all.
Hello, everyone. Thanks for joining us. Thanks, Mike and Stephen, and Tatsuki. Sorry. So my name is Avik Das, and I moved here from Silicon Valley about 2.5 years ago. So my coming to Japan coincided with the starting of this group. So Mike and others roped me in. So it's been fun growing the community. My background is in robotics, vision-based navigation control. I've been doing it for 20 plus years. A lot of government-funded work, commercial work, self-driving cars, drones, etc. So, but we'll find out more as the evening progresses. Thank you.
皆さん、こんにちは。Hello, my name is Tatsuki Adanier, and I'm doing my own company called AdWarp for now 7 years, and recently I'm doing the construction and the robotics. And later I'm gonna tell about what we're now doing. We are now doing the remote control and the autonomous. And today, thank you for coming and in this happy Halloween. And this lunchtime, I was so excited because the Dodgers won the game. But today, I know that Mike is the Yankees fan because I was, yeah, he's my best friend from the United States of America, like 10 years. But I forgot he born in the New York and the Yankees fan. And also, I'm really big fan of the Japanese baseball. And tonight, the SoftBank and the Baystars is fighting now. So please let me check the game in this session. Thank you so much.
You have my permission. That's fine. Go Hawks. Awesome. Thank you. Sorry, Yankees. I'm not a Yankee. So yeah, thank you, Tatsuki. Thank you very much for that. So we're going to start out tonight talking. I'll take on a brief overview of how we want this to go. So we're going to talk for 5 or 10 minutes about sort of what we're calling traditional construction, so non-automated construction, including tools and tasks such as welding and things like this. And then we're going to hopefully point out places where we think autonomy could help that. Then we're going to transition into just giving a very high-level overview of what we mean by automation and robotics. Really good to get terms down. And spoiler, basically dull, dirty, dangerous. As many people know, robotics is trying to solve by and large. And then we're hoping to bring that together and have a group discussion of where we see automation being applied to construction and similar fields today. And some of these folks have direct experience with that. So that's going to be awesome. And then in between those, Tatsuki is going to be checking the baseball game. So we'll make sure. Yes. So I will let you take it away. Yeah.
No worries. Let me share some material because that's what we do. But you've got to stop sharing before I can do anything.
Problem.
So Mike has given me the unenviable task of talking about construction more broadly. I'll preface this with the, sorry, am I too quiet? I can speak louder if you need me to. I'll preface this with the perspective that I'm working for an OEM, not a general contractor. That'll be a little bit clearer on some of the later slides why that matters. But there's people at CIC who know a lot more about the construction flow than I do. I'm happy to point you in their direction if you want to drill down on that, but I'll give sort of a high level view of how the industry looks just so people who are really unfamiliar with construction can sort of put a frame around the discussion tonight is my intention. So this slide here, a lot of the things you'll see because I'm here in an unofficial capacity, are just stuff I've grabbed off public available information, the sources are there too. This one here is just talking about how big construction is as an industry. It actually makes up about 13% of the world's GDP. So it's a huge industry. But one of the big issues that we see in the industry is that there's a real lack in increasing productivity. I've got a nice graph on that on another page, but 1% over the last 20 years. So it's not going very far. And this is a slide actually which references McKinsey, but they think there can be a $1.6 trillion unlock if you have higher productivity in construction. So when we talk about construction, it's probably worth framing what the roles are, and this helps to frame the context of why it's so difficult to get innovations such as robotics into the construction space. On the left-hand side of this slide, this is sort of your really basic approach to how construction projects tend to work. It's called design, bid, build, so DBB. You have the owner, obviously this is the person who ends up occupying the building. They outsource to the architect who designs what the building's going to look like, and then the general contractor comes in and bids for that business based on those designs. So I don't have the percentages on top of mind, but a huge amount of contracts actually end up in litigation. So they're settled in the courts rather than amicably, just because the general contractor always says what the architect's designing is impossible to build, blah, 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 I need more money. So it's a lot of fun. So this is one of the reason to talk about this is each of the roles in the construction space have a very different objective. So it can be quite hard to get different people to sign off on getting these innovations into that space. So that's the background on this slide. Again, Mike, jump in if you think there's anything we should double click on.
This is 1,000 times more than I know about construction. So please, you have
Again,
free reign.
it's 1,000 times less than a general contractor would be able to add, but yes, if you want to double click, be the questionnaire.
Sure.
So this is sort of how the structure tends to work. So the players, as on this previous slide, this is the structure you tend to develop, do the design and engineering. Again, this is all publicly available stuff. You can just Google it. Then there's the supply of the materials, the components, the equipment. It's distributed onto the sites where it's assembled, which is obviously a large part of it. But then there's the operation portion as well. So construction doesn't finish after building, but what we focus on at Hitachi Construction Machinery is obviously on that the civil portion of that construction, rather than the vertical portion, which is where your general contractors have better angles. So I'd like to highlight some of the pain points, and this will probably lead into the discussions on what we can do. One of them was obviously emissions. So up to about 85% of the embodied emissions are actually in the product phase, while the products are being built and constructed. And we see here on the right-hand side that about 25% of global emissions are coming from the construction industry. So it is ripe for disruption in that space. The other two things, which will tie very well into robotics discussions today, are around productivity and labor shortages. So I was mentioning earlier that 1%, you can see the graph on the left-hand side here, construction from 1950. This is very US-centric, if my memory is correct, but has almost done nothing. The amazing thing is how much agriculture has grown because it's a very limited digitalized industry. It's quite, let's say, rudimentary in a lot of spaces, but the productivity increase has been amazing. The other thing is the labor forecast. So there's a lot of spending which is expected to come through the pipeline. Again, this is a very US context, but things like the Build Back Better bill, et cetera, are pumping a lot of money into the construction space on underinvested infrastructure, but there's just not the people to come in and fill those gaps. So we talk to a lot of suppliers who want to bid on contracts, but they just don't have people. So they just can't go out and bid contracts because there's not enough people in there. Yeah,
I have a question.
Yeah, sure.
So regarding the labor shortage, do you
Yep.
find that there are more shortages in certain parts of that chain than other parts? Like maybe a lot of people really don't want to be on the site building, but they're okay with doing transport or, production.
It depends. Yeah, that's a really great question. And the answer is it depends. To expand that answer a little bit more, it depends on the country. So if you talk about Japan, the 24 Nijuyone Mondai that people talk about with the labor laws, which are impacting a lot around transportation, you don't have enough. People aren't allowed to work as longer hours from a safety perspective. So different markets have different issues, but globally there's just a shortage. There's just people, I think, let me give US numbers again, sorry for being so US centric in Japan, but 41% of people I think are scheduled to retire by 2031 who are in the industry at the moment. So that's across the industry. So it's a really industry-wide problem there.
Gotcha, because I think, if we can find and target those specific points in the chain
Yeah,
rather than just
100%.
throwing sort of blanket, one size fits all, this is automation, let's solve it.
Perfect, yeah,
There's
that's
very
exactly right.
tailored problems, I'm sure, for each point in that chain.
Completely agree, and I'm sure our friends here will be able to speak to that as well, right? Do you have comments you want to jump in?
Yeah,
go.
because my work is like making the system for the construction site. So every morning I have to go to construction site like 7 or 7:30 a.m. and do the stretch, but no young people, the elder. So now it's okay, but the 10 or 20 years, it's gonna really tough situation.
Exactly right. So it's a global problem, and particularly in advanced markets. Go for it, Avik. You want to comment?
Yeah, I mean, definitely, it's challenging Japan to diversify the workforce. So yeah, the Obayashi, people, when we were working on the project, we'll talk about later. Yeah, I had to go to the site, and I was scolded once for being 3 minutes late, but to join the exercises. So it's pretty serious. But I noticed there was the older people definitely, but there's a lot of women in the construction side, which is unseen in most countries like the US and stuff, which was kind of interesting. So that's the other side of the story. So they're definitely diversifying the workforces. But in terms of challenges, there is a separation of physical labor, what is like really back-breaking work versus time wasting. So so the pain points are different, but it seems to be the decisions are made by whoever runs the site. So you may think something based on logical thinking, but it may not map out to what people are ready to accept or use. So that's been some of the observations.
100%. So then I thought it might be interesting to double click on the innovation space. So this is sort of a heat map made from our friends over at Zacco Ventures, who are a really cool venture capital company in the US and Spain. I think they're based mainly. If you want to look them up, I can recommend them for sure. And this is sort of a heat map showing where a lot of, these are all startups, sort of, not all of them, sorry, but a lot of them are startups trying to innovate in different spaces. So you can see there's task-based or there's general purpose sort of innovations happening in the space. I'm sure Mike will speak a bit more on what robotics are geared towards in terms of the areas that they perform well in. But you can see some of the things are going off-site. If you remember back previously to the slide I showed from McKinsey, where there was a lot of production happening. If you can do that prefab off-site, that's a really good way to try and leverage some of the productivity gains that we saw in manufacturing, because you're able to control a lot more of the environment, right? So prefab is a really interesting area, particularly on not just productivity, but also on sustainability. Now, on-site works, things that are highly repetitive, I think you guys will speak to it much better than I do, but they tend to be areas which are ripe for disruption, or things where just human bodies aren't really good at. So you can see Hilti here, they're obviously a very large company, but you have to drill things onto the roof a lot, and they're a drill company, so they came up with sort of innovations and robots that can help you to do that, just reducing the burdening on that aging workforce. This is a really cool map if you guys want to look it up. Let me also maybe just speak a little bit on how we think about this then from an OEM perspective. So we've gone quite broad. I'm going to go super narrow now, and you can tell me if that's interesting or not. But this is how we sort of look at the future of construction sites. So we think it needs to be a lot more connected. It obviously needs to be a lot more digital. You can see things in there like drones. You can see the operator in the construction equipment is actually external to the equipment itself. So remote operation. You need to have that collaborative safety. So you need to have the robotics on site from an OEM perspective, able to interact with humans as well as with other robots while they're on the site, and just bringing that data together then and taking it up another level and being able to use that data. There's a lot of a treasure trove on that side, we think, as well. So there's two ways that we're looking at this from an OEM perspective, again, being quite specific, so you'll have to forgive me for that. But one is having that real-time digital twin. So construction sites are moving towards having a BIM available, and BIM means building information model. And if you have a really good quality BIM available, you're able to actually measure the progress against how it should be. And then to the how it should be, you need to be able to bring that data out of the site really effectively. So we've made some investments in that space in some Japanese startups, which are helping us to do that. And the second thing we're doing from our side is this, we call it Z-Core. I've got to mention the brand names, obviously, but this is sort of a platform approach we're trying to take. So you can see here it's recognize, make judgments, execute. We think as an OEM, we should be doing the execution, but around the recognizing and the making judgments, that can be using sensors to understand the actual environment the equipment's in. The judgments don't have to be made by us is sort of the angle that we're taking this on as well. So we think we know how to execute really well, but apart from that, we think collaboration is probably the smartest way to move forward, just for the way things work on sites. Yeah, go.
Quick question,
Sure.
if you can go back one. The Z-Core
Yeah.
in there, how much is that sort of a black box versus you can define inputs to outputs? If you say it's sort of making judgments for, is it very definable, or is this more of a potential for hallucination, Gen AI type?
No, it's not. It's a lot more stable than that. Again, I'm not an engineer, so you'll
Yes.
have to forgive my
Sure,
sort of very
sure.
shallow answer. But the way that we're thinking about it is we want to have the execution interface so that we're able to receive instructions from that make judgment portion. But in some cases, we will develop the logic that makes the judgments as well. So that's sort of how we're thinking about it. It's not a Gen AI sort of approach. It's a shift to be able to have the equipment doing what people want to do it, rather than people having to tell the equipment what to do every
Yeah,
time.
so very sort of well-defined input to output mapping.
It has,
with
at the moment,
some-
particularly, it has to be just from a safety perspective as well. But yeah, as startups come in and start to do amazing things, I'm sure they'll take it out of our hands and do really cool stuff in that space as well.
So my guess here is, and I've seen some of the demonstrations of Hitachi, the sort of remote cockpit demos, etc. So I'm guessing this is the drive-by-wire part, right? Where essentially you're taking the human out of the machine, but whatever the human is doing, in this remote cockpit thing, it has to work exactly like he's on there, right? With the feedback closing the loop. So this is pure, going back to the beginning of, drive-by-wire, essentially. So this is the first layer, and this obviously has to be as reliable as, anything in the automotive world, right? So that would be my guess.
Actually, this might be, how many more slides do you got? So this might be a good transitional point. Do you want to explain what drive-by-wire is in terms of sort of traditional robotics and automation?
Sure. Well, drive-by-wire is essentially a way of saying that before we had cars that were you could basically send commands to and have things move, like for example the steering wheel or the gas pedal or anything, or you can even think of a plane, right? So basically it was all mechanical, which means someone actually had to be there, push something, and that would be a hydraulic or whatever, and would push something and something would get actuated, something would move. But instead it all became let's say computer control, in the sense they were all electronic signals on something which was called a CAN bus, which just meant that there were digital information being sent all over the car, and based on certain little computers receiving that information, it would do certain things like put more fuel into the engine, right? Or increase the brake pressure. Things that were all done by the human, now a computer has to be able to do it, but the computer doesn't have arms or legs, right? So that's why the concept of wire, as in is wired by digital means, but it's actuated by a computer, essentially.
Thank you.
Welcome.
So essentially, this is, you want to apply these same concepts, but to larger, potentially more dangerous vehicles that, are supposed to, pick up much larger payloads and go further, faster, stronger. So I'd imagine there are challenges related to transitioning from sort of, just commercial vehicles to these vehicles. Do you want to talk, do you know a little bit about some of those challenges?
Yeah, sure. I can speak about challenges. That's all I get told when I go to talk engineering about doing new things, right? So connectivity is a big one. So this is really where 5G has a lot of promise. Whether it's being delivered or not is a different topic, but the ability to pull the data out of the equipment, if you're going to be remote, you need to have that really high quality mesh network. Like you said, you want to be able to mirror what that operator is giving in terms of instructions. When it gets to more autonomous, so long as you're not making the decisions in the cloud, I guess you can do it at the edge, right? You sort of take a little bit of the connectivity buffer. You need the processing power, but you take the connectivity risk out of out of play in that one a little bit. Yeah, and the other one is obviously adoption. So it's just people being able to see that there's a return on investment. So like I said, there's a lot of different layers in the project. So if you're talking about equipment, generally it's working with those subcontractors. The subcontractors are working on quite thin margins. So in order to convince them that it's worth doing remote operation or autonomous operation, either you need to work with someone like an aggregates or like a cement plant, where they have really repeatable work and they therefore are able to really easily calculate that ROI, or you need to be able to explain to someone how, if you reduce this from 3 operators to 1 operator, you can pay for it in 18 months and then stuff. And that means that you've then got those additional resources to, as I mentioned earlier, bid on those projects that you couldn't bid for. So did I answer your question?
Absolutely.
I hope I covered it. But
yes,
yeah.
and I want to come back to adoption, both in terms of the specific task and the people doing the tasks, and in terms of maybe human capital or money that might be blockers for this. And then also I'd love to go into cultural adoption as well, because there is definitely an analog to this when robots started to be introduced into factories in the 80s, especially in the American Midwest. There was a lot of pushback to that. Before we get to that, I wanted to switch over to Tatsuki for a second. And talk about one of the challenges you mentioned, which was latency and connection. So Tatsuki, you've done a lot of work with teleoperation of these machines. So I can show some of the videos that you sent if you want me to.
Or I can share.
Yes, perfect. And then if you can talk to some of the challenges there.
Okay, so I'm going to share my screen.
While he's setting that up, one comment about networking is I think sometimes I joke that people jump to autonomy instead of remote teleop is because of the networking problem. They just no one wants to solve it. So.
Yes, so first I'm gonna tell our company's use case, and this is the construction site of the dam in Akita. This is called the Naruse Dam, and this construction site is the Kajima's project. It's opened, and we control this tower crane from 1 kilometer. Yeah, just control this crane from like here.
Is there anybody in the crane at the time as a sort of safety backup, or it's just fully no one's in there?
No one's in there.
Wow.
Yeah, so this is the cockpit. But the point is it's still 1 kilometer, but it's the dam. This is the construction site for dam, and the dam is really far from the city. So no one wants to go to there. So now it's the 1 kilometer, but they want to be more long, like not a 1 kilometer, just a 10 kilometer or like a 50 kilometer. But the point is that if some accident happens, who gonna care? The real example is the sander. The sander is because the crane is really high, so the sander is really often attacked. But after the sander attacking the PC or something is broken, but who gonna care? So that is the current the facing problem. And the latency, yeah, of course, it's really important. But recently, now we can do the Zoom or Teams. There's a lot of the technology. So currently, latency is not a problem. It's gonna be more, how to say, like more the construction site, like a more safety or if we're gonna care like that.
I guess if you're not operating in terms of, like silicon wafer processing or even online gaming, like you're not sort of operating at those speeds that you need to necessarily be super quick. But I'd imagine that there are certain places where you would have to catch that. I'd imagine if you had some sort of, for example, a safety system that's meant as a backup for a wire breaking or something, and something needs to act very quickly. Are there any critical points in the chain that need super low latency? And is that possible now from a distance of 1 kilometer or more?
So currently our technology is like okay. I'm gonna show the example. Wait a minute. Which one is okay? So this is not the construction site, but this is about the forklift, and this is me, and I'm in the Los Angeles, and this forklift is in the Chiba. It is I forgot but it's really far. Then the latency is about 0.8 second from the United States to Japan. Inside Japan, the latency is more or less than the 0.3 seconds, like that. Then the 0.3 second, it's okay, but after like more than the 0.3, like a 0.5 or 0.6, the human gonna feel the latency. It's gonna be late, so it's a little bit more dangerous. So that's the point, but the technology is now coming.
Can I comment on that one? We had the same problem on construction sites when we had people operating remotely. Around 0.2, 0.3 is a really good line where, like you said, there's a lot of older people on construction sites and they've been doing it for a long time and they're like, this game doesn't work, and they just get frustrated and go out and sit in the equipment. So yeah, that's a big issue.
As long as they don't rage quit the construction site.
Yeah, we could have a whole session on latency, so I'll skip my comments. But I used to work for SRI International, and when they first did the first iteration of the Da Vinci robot, which became the intuitive surgical robot, it was for remote battlefield surgery. So so we're talking like thousands of kilometers, and they even did a demonstration of it. Basically, it was remote in space. So I guess there are strategies to deal with latency, and many ways to solve it, I would say.
Yeah. Are there other industries that you both are looking to as an inspiration? For example, space. I know that there's especially Japanese space companies that relay to the moon, Mars, even. And then again, like I mentioned, gaming. Are there companies and industries that you're looking to sort of help you with that lag? Because I'd imagine that could be a big issue.
Yeah, now recently we use the Starlink for the remote control. For example, we try to control the tower crane using the Starlink system. Like put the Starlink antenna on the top of the crane, and we're gonna control. But the problem is the it's gonna the connectivity is sometimes unstable. But so we're gonna do the more the technology. But to the moon, maybe it's gonna be maybe 1 or 2 second latency. It's gonna be more huge. So we should put some AI inside the construction site and or just work by themselves. Or we have to create that kind of system, I think.
Exactly what Avik was saying.
Yeah, I was trying to say that you have to build more intelligence on the edge. Yeah, essentially.
So actually, just very quickly related to that, and this reminds me of something that Toyota was focusing on. So instead of going for example, in self-driving, instead of going for full autonomy, they also had a driving system called Guardian that was sort of a shared autonomy system. Do you see this in construction now? Just sort of the introduction of some sort of mild autonomy to help assist rather than full autonomy or full teleoperation?
Yeah, 100%. Can I share a video? Would that be okay? And do you have the score on the game as well? Have you been checking? We forgot to ask. So give me 10 secs. Sorry, guys. Oh, where did the PowerPoint go? No, it's not allowing me to share the PowerPoint anymore. Yeah, I can do the whole screen. Sorry, guys. Technical issues. There we go. We're back. So there's a few different angles. We didn't really touch on it too much, but the thing that robotics are really good at doing is repetitive tasks, right? And the thing that is often happening, let me go to this one maybe. So the thing that's often happening when you're doing excavation, and how do I go full screen? I can't. Never mind, okay, sorry. Everyone will just have to have their glasses on. The thing that's often happening when you're doing excavation is, number one, you might be far away. So for us, the similar analogy would be in the mining space. So mining is often happening not next to cities, it's happening where the mineral deposits are. You have what are called FIFO workers, fly in, fly out workers. They're normally 2 weeks on, 2 weeks off. And they have really, really high salaries because it's not a very nice job. So you're talking easily hundreds of thousands of dollars per headcount. In the mining space, all of the OEMs, including us, have already basically automated the dump trucks. So that's low-hanging fruit. When you get to the excavators, again, you guys know better than I, but there's so many more angles that you have to work with that it's not as easy to do. So what we see happening as sort of a progression is there's that driver assist function, like you said. So you can see here, it's sort of assisting the excavator operator. This is linking back to the experience. When you're losing those experienced operators, they're not getting as much material in the bucket because they don't have the experience to know how to do that. If you're remote, you lose some of that feel as well, linking to gaming. That haptic feedback is actually a really interesting thing to be thinking about in terms of these remote operations. And then you're doing what you see in this video. You're picking it up, you're putting it in a truck, you're picking it up, not very exciting. And humans, in my understanding, kind of suck at doing the same thing over and over and over again. Robots do not. So for example, on this excavator, you can see he's about to hit the truck. It'll automatically lift up for you. So it's sort of a driver assistance system that takes away the boring parts. I wouldn't say there's so many exciting parts to digging stones, but it takes away the boring parts. It helps to improve the productivity then on site. And then that's sort of where everybody's already starting to play from an OEM space. It will move then towards, if you have the connectivity, the remote operation, because the harder parts still work better with humans. So that scooping, that loading, you can assist on it, but actually humans are much better at doing those tricky parts. Point-to-point automation, it's not that difficult, right? You run a path, you tell the robot, in this case, a wheel loader or excavator doesn't run point-to-point, tell it where to go, it does it. So and then after that, you'll get into, once you have enough data to understand how the best humans are operating the equipment, that's when it'll come back into your full autonomy play around.
So this I switched mics. This was going to be my next question. So there's something called imitation learning as well, which is sort of taking motions and experiences from humans operating robots and then incorporating it and having the robots learn how to operate. And it sounds like there are aspirations or at least beginnings of doing this. Avik, I'm sure you have something.
Well, I mean, I personally am not working on this, but I have noticed because we are working a lot with warehouses and forklift. So forklift automation, that was cool to see that video. But you're aware of your TRI, ex-TRI person with third wave automation. So they're the people working on the true like fully automated forklift, but they realize that there's not going to be an automated forklift overnight. So instead, what they did was instrumented the forklift with as many sensors possible, sort of like a self-driving car of forklifts with lasers, everything. I don't know how this all networking, but regardless, they have enough cameras and lasers, and they started with this notion of shared autonomy. So the idea is the same because they were able to train in simulation and however to do the task, but when it came to an unstructured, a real warehouse, it was almost impossible to guarantee. So what they did was the forklift would, as you said, go from point A to point B, and then it would try to do the task, and the operator would be either, I don't know the exact details, whether they are, the operator is on it all the time, or it only, alerts the operator before, but the idea is the same. They're basically collecting data from those trials, recording everything, and the idea is that eventually, the system will learn how to recover from those situations and use them. So it's sort of could be called imitation learning, but imitation is not a really good word, I would say. It's more like some sort of reinforcement learning, I would say. That would be my thing on it.
That sounds great. And the company was Third Wave Automation. Shout out to Arshan Porsohi, my former manager at TRI. So unless anybody else has anything to say on that,
I have a question about Stephen. I'm gonna share our
And then after this, if you wanted to share your,
Can you share? I didn't bring.
I can absolutely share it. Sure.
So now we're wondering this is one of our client. This is the charcoal site in the factory, the material factory. They have their own how to say in the it's
Their own
the
power
electric-
generation.
Yeah, power
Yeah.
generator, and they have to put the charcoal every time, every hour, in the 24 hours and 1 year, every day. They cannot stop to put charcoal, and there's a 8 person is control this 3 machine, but the average age is the 50. So can you help this problem?
Well, that's what we need to do. So I think this is a perfect example of what I was talking about before in the aggregates plants. So we see in cement plants and these kind of spaces where they're not doing difficult things per se. Depending on the consistency of the material, one of the reasons you want a person to be doing the loading and the unloading portion is what happens if you hit a large rock. What happens? I mean, look at Waymo, right? Look at how much time and money they've raised billions, and they've spent a lot of time on those edge cases.
Yeah.
I was talking to a guy from Waymo the other day. They said they know every 300,000 miles, at least one person is going to be on the hood. That's an edge case that they can, every 300,000 miles, they know they've got that now. And that's because they've driven so many miles. So that's sort of the level of data you have to build up in an uncontrolled environment. But for these kind of environments, the difficult thing is the changing of the topography.
Yeah.
So if you're talking about mining sites, automating dump trucks, after it rains, you have different terrain that you're operating on. If you always follow the same route, you're going to create ruts. You're going to have problems then. So these kind of use cases are perfect. This is the kind of thing where autonomy or remote operation will come in first, is my opinion.
I really want to introduce you to our client, but the problem is our client don't have enough budget. So
Common problem, yeah.
Yeah. Like for example, this operator 1 month 30万円 like for the payment. So they don't have enough budget. So they asked me, like how much then what you can do, like that, the cost merit.
Let me give you a US example because we spoke
Yeah.
to a company in the US on the startup side actually that was trying to solve this problem with a semi-autonomous operation. And their ROI, they are not cheap in terms of the cost to have their equipment retrofitted. But their ROI was if you can go from 3 people to 1 people, it more than pays for itself in 18 months. Now that's US grade wages, so it's probably a little bit more of a payback period in Japan, but it does pay for itself if you are patient and you have the cash flow to have that upfront investment, it can pay for itself.
Okay, this company is in Yamaguchi, so I'm gonna introduce him to go to Yamaguchi. It's really far.
We've made a love connection, everyone. If your companies want to go on a second date, we'll pay for it. That's fantastic. Great.
Yeah,
Great, great, great.
Yeah, this is one of our real examples. Thank you.
Very nice. So I'd like to transition a little bit from a very sort of unstructured environment in terms of the consistency of the ground you're driving on, the fact that when you are basically doing your job, you're also getting rid of your mobility points, like you're getting rid of road and structure. And Vic actually worked on something more for material transport, which is another point in the chain that could use automation. So I'm going to show your video now if you can give me, thank you so much. Let's see here. If you want to start talking.
Yeah,
Vic,
well,
you
I wanted to say
give
that
them a preview.
there is a company that's doing mining truck automation called Safe AI, and they are in Japan too. So
No, Beavertree, yeah, the CEO there. So yeah, he works
so
with
do I, he's a
Obayashi
friend.
here in Japan, right?
Yeah. So it's all the connection. So this use case, this is a project that I worked on when I was with my previous company. It was called the Smart AGV project, and the client, and this is from a public press release, so there's no secrets here. And this was completed in 2020, so it's been a while. And people might be curious. Oh.
Interesting. All right, we'll see if we can fix this.
Do you want to try do you want to share the link with him? Maybe it will play on
maybe.
Windows computer. I think Mike has an Apple device, maybe.
I do.
Yeah. Anyway, coming back to the history of the project. So basically, Obayashi is a big company. They're one of the top construction companies in Japan, and they had a decent budget for R&D. So they were always interested in looking at what their pain points were, and they had this idea because they had a Silicon Valley innovation lab. So the idea was they floated the problems as challenges. And the idea is, can you solve our challenges and we'll fund you kind of idea. So the pain point here was the fact that on Japanese construction sites, commercial construction, like, big hotels, etc., there are large sites, but they're also very, how should I say, constricted sites, right? There's very narrow corridors. And so after the construction reaches, okay. So after the construction, do you want to pause it for a second? Yeah, okay. So the idea was that because the site, after they have built up the scaffolding and the floors and maybe the walls, the idea was that there was still a lot of material that needed to be moved from the ground floor where the trucks would drop them off to where it needs to be for the worker to work on it, like drywall or large metal frames and things that basically needed to put up in a specific location. So imagine now the worker comes in, does the morning exercise, and he's all ready to go to do his whatever he's skilled at, but instead he has to take a low horrible little cart, put this heavy material on it, and then push it all the way, use the construction elevator, go up to the floor and deliver, and keep doing this until enough material has been accumulated so he can start his work. So this, to them, was a huge pain point, and they wanted to solve it with these, you can play the video, with these AGVs, and they were basically pretty cool. They were very proud of the design, which meant that it could literally go under the pallets or whatever. If you put it on 2 lumber kind of supports, it could just go under and lift up with its whole body. And it was very low, and it had mechanism wheels, which means it could move sideways. So normally normal wheels can't roll sideways, but this robot has special wheels, which means that if it is carrying a very long and heavy load, but wants to go down the corridor, which is narrow along the side, it can move that way. So those were the special things. But the problem was they had the AGV, but they had no idea of how to move it autonomously. So they had joystick control, and they came to us, and we developed the entire autonomous system using, computer vision and LiDAR that's on the robots, and it was also coordinating between multiple robots to do the job. Now, this was challenging for a couple of reasons. One was, of course, the fact that you're carrying this load that's bigger than the robot, which is not usual, right? In robotics, normally, you don't have to deal so much with robots that are carrying loads that are bigger than the robot, right? So that was one challenge, which means you had to have some idea of, what you're picking up, and and that's going to affect, you might hit a wall because the load is bigger than you. So that was one of the challenges, and the environment was changing every day because it's a construction site. They're putting up, walls and structures here and there. So it was a visually very hard environment. And the technology that I'm working on with my current company, Guide Robotics, is the same. Basically, it's the GPS-denied navigation and situational awareness, and that's what was enabling these robots to do their job. Now, all this is interesting in the sense that we delivered the autonomous system, which worked as expected, which meant that literally the site manager would put up a mission which said the loads are going to be delivered at these locations, and they need to show up at these other locations. So including, talking to the elevator, all of that. Now, everyone wants to hear, probably wants to know what happened, right? So this was 2020, and this was delivered. So are they using it in every site in Japan? Well, the answer is, while this was introduced very gently with multiple demonstrations to the construction sites, and everybody liked it, but when it came down to actually using it, the older people at the site and the managers, they were essentially not comfortable with fully autonomous robots moving around on the construction site. So they would rather they preferred to have it remote control. So this was another case where, again, networking was terrible. So that's why, this autonomy would have been easier. But instead, they were like, no, we want remote control. And remote control initially was just joystick, but then you have to basically walk behind the, so that's where things are at.
So I'm wondering if this is an issue of either it being too advanced, where they want to scale it back and have some more control over it, or perhaps there's other technology that can help here. So it depends on what their pain point would be. Maybe they didn't want it to be autonomous because they couldn't predict what it was thinking at any moment or where it would go, in which case we can maybe solve that by having projection mapping of the path it's going to take, some sort of augmented reality. What in your opinion, was their actual pain point?
Well, our system actually had a full API which showed what it was going to do. There was no generative AI kind of stuff. Everything was pre-planned and demonstrated. It would say what path is going to take and all of that. So all of that was there. I don't know if we can say it was too advanced, but I can say that in a big organization, you often have the product team, the R&D team, and then you have the external vendors, right? So in our case, I think we basically had the R&D team look at a pain point and come up with their idea of what would solve it, rather than getting more feedback from the end user as to what was acceptable. So, I mean, for me, it was a great project. I got to come here, and that influenced my decision to move here. But from a market study kind of view, I would say that the business case was kind of weak. But I think there's other applications where we could apply similar lessons, right? So where automation is possible, question is, does the end user want it, is okay with it, likes it or not?
Did it improve productivity on the site?
I couldn't answer that question because because of COVID, I couldn't come for the final round of testing, whatever. But if you think about it, we're talking about the funny thing is safety. You talked about safety, but they basically were supposed to run these after hours, right? The whole point was the deliveries happen at the end of the day, and this thing works at night and and then the morning you come back and it's fine. So the question is, how do you measure productivity for something like that, right? So Did the workers have extra hours to do whatever they were supposed to? They were probably like, damn, I could have spent some time walking around moving things instead of, putting up drywall all day, right? So I don't know.
There might be an aspect of pride there, personal pride, pride in your work. So this sort of brings us back to adoption of robotics, in factories in the US when they were first being introduced. Specifically, I come from Kawasaki as well, and I heard stories of when robots were first being introduced. They would go, put them in the factories, and then maybe come back a day later and they would be vandalized. They would, nothing so much as like strikes or protests, but there was definitely a pushback against automation because the perception was this isn't going to improve my productivity. This is going to completely replace me and put me out of a job. So did you hear any feedback like that? That no, we want to have the controller because we still want to be, in the loop and prove that we're, basically a crucial part of this system.
I think it definitely had something to do with control. And one of the issues was there was kind of a little bit of hesitancy because of the networking, right? So because of the wireless networking, uh, if the AGV system decides on actions and is trying to communicate to the, whoever's watching or not, right? It still has to use wireless communication, right? So that was one aspect where if they were just looking at it and they couldn't see what it was thinking because of the communication, that would give them the sense that they don't have control or they don't understand what was going on. But beyond that, I think it was just that the site manager didn't want yet another thing where they uploaded something from the BIM to these machines and then come back the next day to find out what happened, right? So I think it wasn't acceptable. That would be my guess. And this being Japan, I don't think I can go deeper than that. I mean, I won't get an answer. So
We had planned on originally doing an audience Q&A, but unfortunately we're running up against time. We do have a number of viewers online. So what I'd like to do is to suggest that if anybody in the room had questions, please come and find us afterwards. We're going to be networking from 8 to 9. Anybody online, if you have questions, comments, anything like that, I recommend please go to the Meetup page and join the Meetup group. Even if you're not local and you just want to be part of the group, go there. Also, please search for Robotics X Tokyo on LinkedIn and feel free to post there. I'm sure anybody here would love to discuss and meet. And then just to wrap up over the next 2 or 3 minutes, Tatsuki, do we have an update on the SoftBank Hawks score?
Now the DNA is winning.
Okay, I'm not sure if this
but
is good or bad.
sorry, I forgot to say I'm the Hanshin fan.
Okay, so
and,
very, very different.
It's already loose, so
Sorry.
but it's
Sorry,
okay.
So does anybody have any closing thoughts, ideas, maybe about 20 seconds each, if you want to just promote your company or wrap it up in some sort of way, feel free to, we have a couple of minutes.
Okay, so finally, now our company is doing the remote work, but recently the autonomous working is growing. 2 years ago, my work is the 100% remote, but now the 70% is autonomous and 30% is remote. Maybe this rate is keeping. So if you're wondering about autonomous or remote, just tell me here. Thank you.
Thanks.
yeah, well, in closing, thanks again. It was a great discussion. My thoughts on, I think, especially now, we have to be very careful. I think we have to, whenever we say autonomy versus automation versus, like we talked about dull, dangerous, dirty work, and which is ripe for robotics, right? But if we talk about automation, I think automation is I would say, is more like you do the same thing repeatedly without without any knowledge of the consequences of changing your path in any way, right? But autonomy, on the other hand, there's a little bit more decision making. So I think that's where I think robotics people are more interested. I think we are not that interested in automation, but we are definitely interested in autonomy, and more autonomy on the edge. is essential, but I think using teleoperation as a guide to getting there. For example, in warehouses and factories, everybody's out to make a cart that can move things. But the problem is not really that. The problem is these things don't have arms. So if you can't really move things from the shelves onto these things, you're kind of, all picking at one side of the problem. So, I think it's important for us to look at both sides and put equal amounts of energy into both sides to make an end-to-end solution for autonomy.
That's a really good distinction and good point. Thank you. And then Stephen, if you want to take us out, any Hitachi or personal?
Yeah, I'll speak on behalf of Stephen for this
Go for
one.
it, go for it.
There's a lot of great solutions looking for a problem. If you want to get onto sites, it's always going to come down to productivity. Everybody talks about safety. Safety is really important, but safety doesn't pay for itself without productivity. So whether it's sustainability, robotics, whatever you want to get onto sites, you need to go and actually see the users of that equipment and then understand, is this transferable across different sites? Because that's really hard to do because every project is unique. If you want to develop a solution for every project, you'll never get anywhere. But if you can prove there's productivity in doing this solution and adds value to the people at the Gemba, that's when you start to get wins.
That is a word I've heard so much of over the past year working for Woven. Thank you very much. That was fantastic. I really appreciate it. Thank you all for watching us. Thank you everyone online. Our next event will be November 14th, where we're going to be hosting a delegation of startups from Boston, specifically Mass Robotics, so that should be a lot of fun. And then December 12th, we're going to do something to close out the year here as well. And exactly 8 o'clock. Everyone have a good night, and we hope to network with you outside. See you.